Hello, everyone. My name is Kevin O'Hara. I'm the training supervisor here at GSSI, and I will be with you today to discuss 2D interactive in our RADAN 7 software. In today's webinar, I'm going to talk with you about what exactly you can do in this pane, how to add targets, how to control the targets that you're adding, whether you're picking layers or picking targets, and whether you want to pick positive amplitude reflections or negative amplitude reflections. And then at the end, we'll talk about how to adjust the picks that you may have already added, maybe changing the dielectric constant, or changing what those layers are called, the pick ID, so to speak, and how to export these picks out into some other program or into a file that you can work with. As always, if you have any questions, feel free to write them in the chat. I will open the chat and start answering those questions at the end of my prepared material. But if you have anything that comes up, feel free to type it in whenever you're ready. So let's get started with today's material. I have RADAN 7 open in front of me. I have a few files open and ready to go. These are the files that we're going to play around with today. I have a 3D grid with some hyperbolas on the screen here. For some background information, this was a structural survey, a 3D grid collected over a wire mesh reinforced concrete. I can tell it's wire mesh because it tends to change in its depth pretty rapidly over a short horizontal distance, about 20 feet here, and we can see the depth shift up and down by quite a few inches. I'm going to just look at this one file here, and with this one file, I will start adding some picks, right? So to set the background a little bit more so, I have the file open in front of me. This is a 3D grid collected over a wire mesh reinforced area. And maybe my client wants me to determine the concrete cover depth, right? I want to determine how much concrete is on top of all of the reinforcement that I have here. This could be a situation where using the 2D interactive tool can help you. If I want to determine the cover depth, I will head over to the 2D interactive ribbon. Upon clicking on this ribbon, I see what I have access to here, and we're always going to start in the picking tools area. The picking tool is currently disabled. I have 4 at my disposal here, plus an extra one, Easy Tracker, specifically for layer picking. Because we don't have layers here, we're just talking about single pipe-like targets. We're going to stick over here with the picking tools. It's currently disabled. If I click on single point, I will activate the rest of the ribbon here. On selecting single point, I see that I now have access to the objects pane. I also have access to the pick attributes pane. And when I bring my mouse down over the file, after a single left click, my mouse changes from the normal cursor we're used to seeing to 2 vertical bars. These vertical bars indicate where target picks will be added. So before we start adjusting over here, or rather we do need to make some adjustments right away. I have the single point picking tool on, and I look over here in the objects area, and I see that my pick type is currently set to layer. Now that is incorrect in this case here. I'm not picking a layer, I'm picking a target, a pipe-like target. So I'll switch my pick type over to target. The focus is currently set to rebar. The focus is really just a name for this target. Even though it says rebar, and I am fairly certain that this isn't rebar, it's not going to really mistake anything. It's just going to call it rebar for now. I can adjust the name later on if I'd like. So we're going to keep the focus on rebar. The pick type is set to target. And then I head over to my pick attributes, and I see that I am going to pick positive polarity targets. I can also choose negative polarity. I can choose absolute polarity. That means positive or negative, whatever the highest amplitude is where I'm clicking, or none, which would place a target at wherever I click on the file. So talk about polarity a little bit more. By polarity, what we mean is if we look at our O-scope view, disable this for a second, I click and drag to get a scope on the screen. You can see here on my single scan representation, this is a view that you might be used to seeing on the setup screen of your SIR control unit, or for the utility scan or structure scan mini users, this would be the display A plus B option. You can see this right to left, oscillating wave on the screen here. When we're talking about positive polarity targets, we're talking about reflections that exist over on the right-hand side of this central location. For negative polarity targets, that's over on the left-hand side of this central location. Now, for most metallic targets, or rather for all metallic targets, the pick polarity you're going to want to stick with is positive. The first strongest reflection for metallic objects is always going to produce a positive polarity amplitude. So for metallic targets like this wire mesh, positive is going to be the pick here. When we're talking about layers, you really could have a positive or negative amplitude reflection. It's dependent upon how the dielectric changes when it enters that material. For more information on this, I'd recommend checking out our dielectric constant presentations, accessible in the training webinar playlist. The last one we did with Rob Sommerfeld, um, that discusses this, as well as an earlier one we did on the dielectric constant. So I'm going to stick with positive polarity because we're talking about metallic objects here. For the search width, that's less crucial at this point. The search width is currently set to 9 scans. Remember, we're transmitting and receiving scans into the ground, so 9 of those individual wiggly lines horizontally, that's the search width right now. That's really how far apart these black lines are. If you find that your targets aren't going in the location you want, you can try decreasing that search width to 5, 3, or 1 scans, or increasing that search width to 17 scans, where now my black lines are even further apart. 3 scans, a lot closer together. We're going to stick with 9 for now because that tends to work pretty well. So when all said and done, what have I done so far? I've gone into 2D interactive. I know that I need to pick some targets here to determine my concrete cover depth. So I selected the single point picking tool. I made sure that my pick type was set to target, and because these are metallic objects, my pick polarity is going to be positive. So now I'm going to go down to my file, and I'm going to left click at the peak of a hyperbola that I see on the screen. When you left click, a dot's going to go at the highest amplitude thing RADAN can find in that search width, which will generally be right at the peak of the hyperbola. Now, if the dot doesn't go right where you want it to, you can right click over that dot and it will go away. Left clicking again will put it right on back. So I can, if I want to keep everything with the same name, I can keep my focus set at rebar and just left click over my file to add all of my target picks in. If you'd rather differentiate these targets, you can. After selecting one, you can hit new target, and now we're adding rebar 001, new target 002, 002, new target 003, and so on and so forth. Again, if that dot's having a hard time getting where you want it to go, try decreasing that search width, left clicking, and it should go right about where you want the dot to be, at the peak of the hyperbola. Now, let's say you want to do this a little quicker. It's going to take all day for me to left click all of these rebars on file 1, 2, 3, 4, 5, 6, and so on. So what if I want to speed this up? There are a couple ways to mass add targets, and those tools are going to be your select block and select range tools. So select block allows you to, once highlighted, click and drag on your file to generate a block. You can adjust the size of the block by clicking and dragging on these boxes on the corners, on the sides, and on the top and bottom of the box. Now, in order to get this to work accurately, what I want to do is make this box as narrow as I can so that it's running just along the peaks of the hyperbolas that I want to add dots to. You'll notice to help highlight your features a little bit more, whatever the box is over, it's going to shift the color a little bit, and it's actually going to invert the polarity of your reflections. These are all positive polarity reflections, and when I bring the box over top, you see they all shift to a negative polarity. That's just to make them a little easier to see. It will still add the dots in the correct location. Once you have your box in the right spot, you can try right-clicking on that box and selecting Add Points. Add Points will quickly add a dot to the tops of all the hyperbolas that you have highlighted. I found that the narrower this box is, the closer to just the top and bottoms of your hyperbolas you are, the more accurate this will be. So if the dots don't go quite where you want it to, try making this box a little bit smaller so that you're just covering the tops. In this case, it actually worked pretty well, so I'm happy with that. I can bring my box over here, can maybe make it a little bit taller so that I'm covering everything, and I can give that a shot again. And and just a couple boxes, I can quickly add these points and maybe just do a single point for my last one. So there we go. We got a lot of targets here. Now, as you might have seen, select block allows you to do the same thing. If you added a whole bunch and a lot of them seem to be in an incorrect location, you can highlight all of those, right click, and to delete those very same points. Now, another way to do this is to use a tool called select range. Select range, you can think of it as a super select block. With select range on, no matter how big you make this box, it will always go to the very edges of your file. Right? I can drag this in, let go, and it's still going to go all the way to the edge of the file. Now, interestingly enough, for 3D grids, this range goes through the entire 3D grid as well. If I decide to add targets with this, it's going to look at that specific depth range in your entire grid and try to add targets in that range. So this could be a quick way to add all of our targets, and then we can just go back through with the single point picking tool and make fine adjustments if we find that some of the picks aren't in the right spot. So let's give that a shot. I'm going to right click after selecting this range. I'm going to click Add Points. And there we go. I'm going to toggle on single point. I'm going to add in that one straggler here. And we can head through and see that, oh, we have dots pretty much everywhere else too. Right, there might be one or two missing, but for the ones that were added, they seem to go right in the right location. So this is a quick way to add in a lot of targets all at once. Now, it does call them all the same target, in this case, rebar 003, but ultimately that's okay. If all we really want is cover depth, we just really need to know the depths of all these picks. We don't necessarily need to differentiate all of them. So this will be a quick way to get us how deep each target is, and then we can, of course, export that out and obtain the information we're looking for. So we've talked about adding targets with single point select block and select range. Now let's talk a little bit about the other pick type we can deal with, and that's picking layers. Right, so I have a road scan file over here. This is data collected with our horn antenna. I have a couple of layers on the screen here. So now let's talk about how to draw in those layers. I'm first going to start by toggling on the Easy Tracker tool. The Easy Tracker tool's the preferred tool by us if you're picking layers. I'm going to switch the pick type to layer. The focus can stay on layer 1 for now. I'm going to click on Start. And now I can bring my mouse over this and start adding in my layers. So I see a shallow layer here. I see this more distinct layer here. I'll start with this distinct layer here. And I'll left click to add my first dot. You can see in the depth pane at the bottom of the screen, a really helpful pane to have on hand if you're adding layers. Head back over here. After my first left click, I have my first point here. My second left click, I'm going to move my mouse over a little bit, see how far I can take it. And after my second left click, RADAN will attempt to fill in the blanks. Now, it did a pretty good job there because this layer is fairly pronounced, but in general, you want to make sure that your left clicks are pretty close together, because the further apart your left clicks are, the more room for error we have. So, we see some picks were incorrectly added here. I can do a right click to delete only my last section of picks added. So right click gets rid of those. Left click to add some more, and I'll click a little bit closer together, and we'll see the second time around we have a more accurate placement there. All right. So I've added my first layer, and now let's say I look and think, that might be a layer that I'm interested in. I want to add that shallower layer as well. So I click Stop, I click Start, I switch my focus from layer 1 to layer 2, and then I start adding my second layer. So I left click to add one dot, I left click over a little bit to add some more dots, and I'm clicking, and I get to this interface here, and I'm clicking, and nothing is happening. So what's going on? Why can I not add targets over here? I can't add targets over here because my focus is currently on layer 2, and layer 1 exists below it. Right, so this is a, I guess, something we have to deal with when we're adding in layer picks in RADAN. When you're adding in layer picks, your layers need to be one on top of another on top of another. So if you find yourself in a situation like this where you've already picked one layer and you now want to add a new layer above it, you don't have to delete all of your picks. There's actually a quick way to change the name of your picks so that you can continue adding the way in which you'd like. And to do that, we're going to make use of those select block and select range tools we talked about earlier. So because everything exists on one screen, I'm just going to use the select block tool for a much larger portion. You can use select range if your target picks go outside of what you currently see on the screen. So with select block selected, I can click and drag to select a block around the layer that I want to change. This is called layer 1. So let's say I want to change the name of it. I want to call it something else. And for good measure, I'm just going to select everything on this same box. I have layer 2 up here. I have layer 1 down here. And all I want to do is change what I'm calling layer 1. So I first need to tell RADAN I am focusing on just layer 1, and then I can right-click on that box. I'm not adding, I'm not deleting, I'm modifying my picks. In this case here, I want to change the pick ID. I want to change the identity of these picks. And I want to change it from layer 1 into, well, we already have a layer 2 up here, so let's call it layer 3. I hit OK. And now, just the layer 1 picks have been changed to layer 3 picks. Notice, because my focus was on layer 1, layer 2 remained untouched. Now I can bring my same big box right back over here. I'm now focusing on layer 2. Now I could just keep it called layer 2 because now layer 2 can exist above layer 3, but maybe I know for sure that that's going to be my shallowest layer. So I focus on layer 2, I right click, I modify, change pick ID, and change layer 2 into layer 1. Then I can head back over to my Easy Tracker tool. I can add picks to layer 1 now. Click Start, click, and continue clicking, adding picks above what was previously layer 1. Now, for this last picking tool here, ground truth is for targets that you actually know the depth to. For layer picking, specifically in the road scan or pavement thickness application, this could be, core data. You've obtained a core, a physical core, and you know physically how deep these layers are. In other applications, this could be a measurement. Maybe you know exactly how deep that target is. You've drilled down to it, and you know how deep these targets or layers are. Whatever it is, you have some physical information, some physical evidence, some knowledge of how deep a target on the screen is. After you've added that pick in RADAN, you can tell RADAN exactly how deep that target's supposed to be. And it will use that measurement to determine what your dielectric constant is, the measure for how fast the radar wave is traveling through that material. Remember, we're always calculating how long it takes for signal to return, how much time it takes for signal to return, and we're converting that into the depth that you see with the dielectric constant that you input. One of the most accurate ways you can obtain this constant is with a physical core or physical evidence of how deep that target is. This is often referred to as a ground truth point. So let's say I've taken a core here, and I know for sure that this layer 1 here, is 5 inches down, right? So I head over to my ground truth picking tool. I go over to my layer, and I need to click directly on this layer. You want to click as close to this layer as you can so that the ground truth point gets locked to the right location. So I click right on that layer, and I tell it that layer 1 at this horizontal distance at this particular location, perhaps where my core was taken, I know that layer 1 is exactly 5 inches down. Now, if you have layer depth information for multiple layers here, you can lock this location to make it a little easier to add those successive points. You would still need to click directly on the additional layers, but you can click not exactly horizontally at the same location, and it'll lock it to the right location. In this case here, I'm just going to adjust this one. I'm going to hit OK, and I now have a ground truth point here. Right? So with that said, even though my ground truth point is in place, RADAN is not using that to calculate the dielectric constant for that depth just yet. Over here, we can see that the ground truth point It's all the way down here, even though the calculated layer depth is way up here. If I want to tell RADAN to use that ground truth point to calculate the depth, I have to perform one of two actions. I can either go to Home, head over to the Tables Other window. The Tables Other window contains, oddly enough, tables of information that I can adjust. I want to go over to the Layers table. And in this location here, I want to adjust layer 1. I can change the name of layer 1 if I want. I can change the color if I want. I can also change the velocity method. I can shift it from an automatic method, which is using the metal plate calibration file for your horn antennas. In this case, I want to use ground truth location, so I'm going to switch the velocity method from automatic to core data. And upon doing so, you can see the target pix locations, they shift down to line up with my core data. Now, this is one way to do it. If you change your velocity method to core data using this method here, this will only use the dielectric constant calculated for the core that the target pix are closest to. So if you have a few cores in your file, it will use whatever core it's closest to calculate the dielectric constant. And that might be okay if you have a lot of regularly spaced cores. But maybe you only have one or two, and you don't necessarily want those, you may not necessarily want those 1 or 2 cores to calculate your dielectric constant for an entire 2 or 3 mile stretch. But you still want to use that core data. In this scenario here, where you have cores but you don't want it to calibrate your whole file, you can keep the velocity method set to automatic. And instead, head back over to Tuning Interactive and make use of our Select Block tool again. You got to make sure that you're focused on the right layer. We're focused on layer 1 because that's the layer that we have our core on. I'm going to highlight the area around my core that I want to calibrate with this ground truth point, maybe plus or minus 100 feet or so. And then I'm going to right click, pick modification options. And this time I'm not going to change what the pick is called. I'm going to change the pick velocity. And I'm going to switch that velocity from automatic to core data. And this will only impact the location I have highlighted. You can see here in the depth pane that only the area I've highlighted has shifted down. The rest of the picks remain untouched by this information. Okay. So last thing I wanted to talk about here is, let's say I have all this information and I want to export it out into something that I can work with. The best way to do that would be to head over to 2D Interactive and utilize the CSV file tool. CSV allows you to use an existing field configuration or create a custom field configuration. We're going to create a custom, and I'm going to hit next. The export category I want will always be waypoints, targets, and layers. Waypoints is where you add in your maybe horizontal distance traveled. This could be for a single file. That's probably all you need. If you're doing a grid, you could do local X, local Y. If you have GPS, you could add your latitude and longitude. That'll give you 2 columns, 1 column with lat, 1 column with longitude. And then whether you're doing layers or target picks, you'll pick the appropriate pane here. We have layers, we have layer 1, and we want the depth of layer 1. Maybe you want the amplitude. Maybe you want the 2-way travel time. Maybe you want how the velocity was calculated. These are all options you can export. If you instead just want your target information, you could select your target pix to target pix depth, and that'll export your target pix depth. Right, so this would be our concrete cover example. Once you have all the data you want in your output fields area, you can hit next. I generally don't filter in RADAN. You can also filter in Excel. It's wherever you're more comfortable with, but you can tell it to filter out values within some range or less than some value or greater than some value if you want to do that. And then you can save this so that you don't have to create this every time. You can give it a name, we'll call it test or whatever, hit finish, and you'll now have an Excel file with those columns of data in there. If you save it, instead of going to create custom, you can simply use an existing. You'll have a custom folder you can work in, and you can select those custom configurations, which will be ready to go right off the bat. Okay, so that's the end of all the prepared material that I have. Now I'll open the floor up for questions. If there's anything